So this is an introduction to parametrics. If you are totally familiar with parametrics and you don't need an introduction, then you can skip this video. This video is about what does a parametric do for you. So parametrics are when your position in the plane is dependent on time. But you're not just moving the way we were moving when we first studied particle motion. We said, okay, here's a particle, and this particle is going to move back and forth, but it's always going to stay on a straight line. It's either going to go, and then we would have a formula for, we'd have a formula for x of t if our particle is moving sideways, or maybe our particle is moving up and down, and then we'd have a formula for y of t. But back when we first started studying motion, we were keeping our particles really boring. They were only traveling on a straight line. But we know that in the real world, a particle doesn't have to travel just in a straight line. It could make a path as it moves around the plane. So it has a change in an x coordinate and a change in a y coordinate because a particle can move in a more complicated path than just back and forth along a straight line. So parametrics allow us to describe the path of the particle with respect to time without having it just go back and forth on a straight line. Now it's moving throughout the plane. So this is parametric equation is for a particle that is traveling in the x and y direction, and we're going to measure time between -2 and 2. So what I wanted to go through with you was how would you graph something like this? And the way you graph something like this is you say, okay, both of my two x coordinates and y coordinates depend on t, so I'm actually going to make a 3-column table. It's going to be t, x, and y, and t is going to be -2 because that's where we start, and let's do -1, 0, 1, 2. And if t is at -2, my x coordinate would be 4 minus 1, which is 3. My y coordinate would be -4. If t is -1, my x coordinate would be 0, and my y coordinate would be -2, and so on. So you're filling in your table based on just plugging t in. So if I want to make a graph of that, I'm going to make a xy plane here. We don't graph t, we just graph the x and the y values. So we're just going to plot those points. So -3, -4, 0, -2. I'm doing it backwards. It's like my first time graphing. 3, -4, 0, -2, -1, 0, 0, 2, 3, 4. So the shape of the path that my particle takes is kind of a sideways parabola. Parametrics also let us describe, as time goes on, what direction is my path traveling. So I can see the direction of travel as well as the shape of the path. So that's an introduction to parametrics. The other thing you can do with parametrics is you can translate them back into traditional rectangular coordinates. The way you do that is you eliminate your parameter. So here our parameter is t. The way I look at this, it's easier to eliminate the t if I solve here for t. So t is equal to 1/2 y. And then I go back to my other equation, and I didn't give myself very much room, so I'm going to go over here. I go back to my other equation, and then I say, well, x is equal to 1/2 y squared minus 1. And then we can kind of see, oh, that's why it's a sideways parabola. That's why it's open up. It's open sideways, but it's open wider because it has a 1/4 in front of the y, because this would be 1/4 y squared minus 1. And that's why it shifted so that the vertex is at -1 instead of at 0. So we can translate back into rectangular coordinates, or we can keep it as a parametric and then just understand that the parametric equation actually gives us a little more information. It gives us the direction of travel as well as the location of the